All right, Econ 120, welcome back. Today's topic is perfect competition. So what we're going to be looking at is this idea that we have many firms, many consumers, and with the firms, there's no price influencing. So they take the prices given. Actually, let me just write it simply. So let's erase all this. So price given. And so that means that one firm can't manipulate prices because it's not going to have much effect in the market. And we'll work through some examples. It's important that you've watched Professor Torres's lecture because he does a lot of the intuition for the stuff that I'm going to be applying today. So here we have the market for books is perfectly competitive and a constant cost industry. We're given that some short run supply and demand curves. So here the short run industry supply curve is given by P equals 4 plus Q, while the industry demand curve is given by P equals 100 minus Q. P is the market price, capital Q is the market quantity. A representative firm's marginal cost is 4 plus 2Q, and its total cost is 36 plus 4Q plus Q squared, where little q is quantity produced by a single firm. So that's really important to know that big Q is not equal to little q. So there's not a typo. Okay. So what we want to know is what is the short run price and quantity equilibrium? Well, it's what we've done before. It's just setting demand equal to supply. So we have supply is P equals 4 plus Q. Demand is P equal to 100 minus Q. So I'm just going to set these two things equal. So 100 minus Q is equal to 4 plus Q. Let's add Q to both sides. Subtract 4, and we get the following. We get 96 is equal to 2 capital Q. And so capital Q, I'll give it a star because it's equilibrium, is equal to 48 units. And so the price, if you plug 48 into either the demand or supply, you'll get $52. So 48 plus 4 gives you 52. Given the price we just calculated, we want to know what is the profit maximizing quantity, little q, for a single firm to produce in the short run. What rule did you use to calculate maximization level? Well, we've always talked about profit maximizing with marginal revenue equals to marginal cost. And that's because you want to, if you keep getting additional benefits, you're going to want to keep producing. And if your marginal cost exceeds your marginal revenue, well, that's costing you more than getting additional benefit. And so you want to stop when marginal revenue equals marginal cost. But in this type of model, we always set marginal cost equal to price. Well, the price in this is $52. And if you recall, marginal cost is 4 plus 2Q. So 4 plus 2Q is equal to 52. Now we're talking about a single firm, so we need this little q. So we'll do some algebra, subtract the 4 to both sides, get 2Q equals 48, and little q is equal to 24 units. So far, so good. Is this firm making positive, negative, or zero economic profit? Well, to get our profit, we're going to get our total revenue and subtract off our total cost, which is equal to 52 times 24, subtract off 36 plus 4 times 24 plus 24 squared. This gives us 48, so 1,248. And this gives us 708. If you don't believe me, just type it into a calculator. And this is equal to 540. Well, that's greater than 0. And so we get positive profits. So firms should probably keep producing in this case. If all firms are identical in this industry, how many firms are in the industry in the short run? Well, in the short run, the total quantity is 48. We found that little q is 24. So what number times little q gives us capital Q? N times 24 equals 48. We get N is equal to 2. So there are 2 firms in the short run. Okay. And then what is the long run price and market quantity produced by a represented firm? And what is the long run number of firms in the industry? Well, in the long run, what we want is marginal cost to equal average total cost. And why is that? Well, in the long run, we no longer consider fixed cost. So what we're going to do is set up our 2 equations. Well, we know what marginal cost is. It's 4 plus 2Q. So let's write that out. 4 plus 2 little q. Remember, we're talking about a representative firm. How do I get average total cost? That's right. You take your total cost and divide by q. Sorry, this should be little q. And that gives you average total cost. And so that's equal to 36 over little q plus 4 plus q. 36 over q plus 4 plus q. Well, let's see what's happening here. there's a positive 4 here, a positive 4 there. They cancel out. So like an NSYNC song, they go bye, bye, bye. And now you have 2Q is equal to 36 over Q plus Q. So why don't I subtract a Q? And you get Q is equal to 36 over Q. Multiply Q to both sides. Here you get Q squared is equal to 36. Well, if I take the square root of both sides, you get Q is equal to 6 units. Well, remember, we want MC to equal P, right? So to get our price, we're going to take this Q and plug it into our marginal cost. So P is equal to 4 plus 2 times 6. Well, 12 plus 4, $16. So before I get the long run number, let's see what's happening here. Each firm now is producing less. Price went down. So it's a good assumption that there's going to be a lot more firms in the market. Well, what is market quantity? Well, let's see if something can give us the market quantity. Well, didn't we find that already? It's 48, right? And so 6 times n, oh, wait, hold on. One moment. So let me just correct something I just said. What we're going to now do is look at the demand curve. So when price is 16, how much is demanded? Well, you take 100 minus Q. You can just flip these and you get Q is 100 minus 16, which is now 84. So to meet market demand, how many firms do we need? Well, there are N firms. They each produce 6 units. 84 units are demanded. Divide both sides by 6. And what is N? Yes, 14. So there are 14 firms in the market. So let me just correct something that I said. To get this number, you take the P that you find and you plug it into demand. Okay? And that's our first exercise.